everyone, and welcome to today's SANS webcast, Using Data Science to Secure Cloud Workloads, sponsored by Cylance. My name is Carol Auth of the SANS Institute. Today's featured speakers are Mikkel Hansen, Sales Engineer Manager at Cylance, who will be moderating today's webcast, and Aaron Bryson, Technical Director, Red Team Service at Cylance. If during the webcast you have any questions for our presenters, please enter them into the questions window located on the GoToWebinar interface at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to Mikkel.
Well, thank you very much, Carol, and hello, everybody. It's a pleasure spending time with you today. Thank you so much for taking time out of your busy schedules to hang out with us today. My name is Mikkel Hansen. I look after the sales engineering team here at Cylance for the West Coast on the United States and of Canada. And I'm super excited to be able to spend a little bit of my day today hanging out with everybody. So what we're going to talk about first is take a little bit of, at first, a little bit of a high level look and then a more detailed look at how data science can help you secure your various workloads. And let's get into it a little bit here. I'm just waiting for the slide to get caught up here. The agenda for today, as soon as the slide advances, is going to be starting out with, again, a high level of what data science is. We're going to break that down into a couple of subcomponents. And then we're going to become increasingly more specific with regards to what data science is and how it can help you. And I'm going to show you a couple of very specific examples of that. And then I'm going to hand it off to my eminently capable colleague, Aaron Bryson, who will give you a couple of different perspectives on securing cloud workloads. And with that, let's see if I can get the slides to advance a little bit. There we go. Apparently I am a little challenged today. There we go, much better. So here's the agenda slide, which we've been through already pretty much. We'll look at what data science is, some subcomponents, why is data science relevant for security, how does it apply to some of the more traditional security layers, and then we'll get a little bit more specific about applying data science to security. And I'll give you an example of how we here at Cylance apply data science to securing workloads. All right, now that I have control of the slides, fantastic. Let's get started, folks. Data science is a term that you probably have heard thrown around quite a lot out there. And that certainly happens for a reason. Data science and the ability for machines to learn and for us to teach machines how to make decisions has really made a big difference in the security industry, as I'm sure it has in other verticals as well. You'll probably be very aware that many of us vendors, we have adopted data science technology and machine learning and artificial intelligence technologies in either existing solutions or brand new solutions. So let's take a little bit of a high-level look at what data science really is. Well, it's defined as a set of algorithmic tools that allow us to understand and make automated decisions. And that's a key point, that decisions can be automated. And we'll get into why that's important in a little bit, using statistics, mathematics, and various visualization techniques. And let's break data science out a little bit in some of the subcomponents of what it really is. One of the first subcomponents of data science that comes to mind when we discuss what data science really is machine learning. Machine learning is a part of artificial intelligence in a broad sense. It uses statistical analysis to give computer systems the ability to learn from data without being explicitly programmed. And that's another key point that I may harp on a little bit during today's presentation. The simple idea that whereas in the past, if you were a developer or a programmer and you needed to make a computer do something, well, the underlying expectation was that you would need to be able to describe and program every single step along the way. And that's not necessarily the case anymore, in that we can simply now teach a computer to make decisions and, for example, to classify something into either good or bad, or red or green, or whatever the classification or the decision point is in the technology we're discussing. Data mining, and again, I use these terms fairly loosely, can be defined as the process of discovering patterns in very large data sets to determine what is statistically relevant and, for example, discover what data could be used to identify, for example, safe code versus unsafe code. And as we go through this presentation, you'll see that I probably will draw a couple of parallels to the universe that we operate in here at Cylance, which has a lot to do with understanding various kinds of code prior to execution and understanding whether executing that code is going to be safe to do or not. Data visualization is a technique that data scientists can use to dissect and understand the data and to refine and build models. All right, so why does data science now make sense for security? Well, for the simple reason that, and I'm sure we all probably have lived this to some extent, that the output of just about any security control that I've ever seen is largely data. And there's so much data, so much information, so many alarms and detections and logs, that if we really truly expect any one person or any team of persons to be able to review all of that and make accurate and timely decisions on that, well, then that's kind of a little bit of a flawed assumption. And that is why data science is so appealing in today's world, in that data science, when done right, allows us to automate and to scale and to make safe decisions based on data, and do it very, very quickly and very, very accurately. In the world that Cylance operates in, one of the very common examples that we talk about is the overabundance of malicious binary executables. That's just one example of a type of data and a type of decision point that data science and machine learning and narrow artificial intelligence helps us make decisions on. So let's take a little bit of a closer look at how data science can be applied to more traditional security layers. So we're all very, very familiar with the concepts of antivirus firewalls and SIEM platforms. Each and one of them greatly benefits from using data science and AI. In our universe here at Cylance, we fall very much into the antivirus and endpoint protection part of the universe, and we use data science in a couple of different ways, and I'll show you an example of that here in a couple of minutes when we get into a brief, slightly more technical demonstration where I'll give you a couple of examples of this. In our universe, we use data science very much to understand whether any particular piece of code, be it a binary or be it a script or be it a command line or anything within that realm, whether that code is safe or unsafe, and we can make an automated decision based on that. In the world of firewalls, well, there's certainly tons and tons of data that can come out of firewalls and either be sent to your SIEM platform or just be ingested by a firewall management solution. And that's another area where AI has really proven, and data science and AI has really proven to be a boon for a lot of folks out there, in that it essentially allows you to really automate and scale up dramatically the knowledge and decision-making power that otherwise would reside within a very, very skilled analyst. So it helps you very much scale and make decisions and take actions on data. Same thing in the SIEM space. I'm a big fan of SIEM platforms simply because you have a ton of data from a lot of different sources. And if you can truly, genuinely make intelligent decisions based on that data across all data, well, then you can really gain some amazing insight and visibility. For example, if your SIM platform sees suspicious communication from an internal device to an external suspicious IP address, and then later that is being followed by data being transferred to such a suspicious IP address. That's one of the simple use cases that that AI and data science can help you accomplish and can help you automate so that you don't have to do that work manually. Now I'm waiting for the slides to advance again. When we start looking at, and so the next part of the discussion today, I'm going to get a little bit more specific again about how we at Cylance use data science to ease the decision making of security administrators, and also to provide some pretty significant value to our customers. We talk a lot about what we call the predictive advantage. And while arguably that sounds a little bit like a marketing phrase, and I will admit that I sometimes sort of tongue-in-cheek poke a little bit of fun at it, it's actually a very, very pragmatic thing. And all it means is, as I'm sure you can imagine, we as a vendor, we have a very, very clear interest in understanding whenever a threat breaks out. I sometimes use the term a celebrity malware or a celebrity outbreak. One of these threats that spread very quickly and or have some particular cynical aspect of it. When that breaks out, as a vendor, we have an obviously very clear interest in understanding whether we currently protect our customers with current shipping product. So when that happens, we have a team of security analysts and researchers across the world who will acquire as many examples and as much information about this threat in question as possible. And first and foremost, very simply, test whether we protect our customers against this threat. And so far, fingers crossed, the answer to that has been yes. And so when we arrive at that conclusion, we'll message that out to our customers. We'll probably post a blog, and we'll probably release a little video sequence that shows us effectively preventing and blocking the threat in question. Now, after that is where it starts to get a little bit more interesting from a data science and from an academical perspective, because what we do subsequent then is we start benchmarking current -1 and current -2. In other words, the previous mathematical model and the mathematical model prior to that, benchmark that against the threat in question to see how far back in time could we have stopped the threat in question. And I'm going to do one more attempt at advancing my slide here, and hopefully it'll work. There we go. I'm not quite sure what I'm doing wrong here with my slide advances here. There we go. That's the slide deck I wanted to arrive at. My apologies for the slide confusion here, folks. So when we look at for example, celebrity malware named WannaCry, when that broke out, on the day it broke out, we at Cylance, we were able to demonstrate and prove that we could have stopped it with a mathematical model and a product that was 23 months old at that point in time. And same thing applies to GoldenEye. We found that we could have stopped that with a mathematical model or product that was 21 months old at the point in time where GoldenEye broke out. Emotet, we found a predictive advantage of 18 months. And so, well, why is this even important? Well, you know, some say that past performance is a good indicator of future performance. And if you happen to believe that that's the case, and that we can consistently demonstrate a predictive advantage that ranges between 12 to 23 months, well, then the notion of, well, how likely is it that I would be protected against whatever may or may not happen in the future? Well, that becomes a pretty interesting question to ponder for a few moments. So the predictive advantage is in Cylance's universe, where we look a lot at securing workloads and securing devices, be it physical or virtual. We don't care if it's in a data center. We don't care if it's in the cloud. The predictive advantage is a big, big part of what we get out of using data science and artificial intelligence. So let's see if I still have control of the slides. Let's do that. Come back here. So in short, applying data science to next-gen endpoint and cloud security and AV products allows you to become predictive instead of having to remain reactive, which is the traditional unwinnable arms race that a lot of security technologies who do not use data science find themselves in. And so with that, I'm going to toggle over to another device here, so just bear with me a moment as I'm going to give you an example of what this really looks like and what this really means in Cylance's universe. All right, so if the technology is with me, and I think it is, we'll shortly see a virtual machine. And I'm just going to preface this by saying the example I'm showing you here is an example of how we, in this particular case, secure virtual operating systems. And by virtue of knowing that, you can then apply that knowledge to whatever part of your organization you might belong to. So what I have here for you is a couple of different things. I have an example of a WannaCry payload that I retrieved from a repository on the internet yesterday. So it's pretty recent. I'm going to expose that payload that is slightly around 24 hours old. I'm going to expose that to a mathematical model from 2015. And once we've done that, I'm going to up the ante a little bit. I'm going to fabricate a brand new, net new, never before seen payload right here with you. And we're going to subject that payload to the same old math model. And so let's prepare for that a little bit. The way I'm going to do this is I'm simply going to use a very convenient tool, and I'm using this tool honestly because it is so convenient. All I want to get out of this is a net new binary that the world at large has never seen before. In this case, I'm using a packing tool. I could do this in a number of different ways, but because it's so easy for me to do on a webcast, I choose to go with this tool. So on this device here, let me just make sure that I have the correct device. I do. I'm now going to do a couple of different things here. I have access to my malicious samples here across my little virtual network. And the first thing I'm going to do is I'm going to grab the original, as of yesterday, WannaCry example and drop that into my virtual machine. And I'm going to go ahead and try and execute it. And the first thing we see is that, well, that didn't really work. I got an access is denied message. And so what actually took place here behind the scenes is that our AI module, our mathematical model that we produced as a result of extensive use of data science, saw this file, saw the request to execute it, and it said, no, sorry, this file is overwhelmingly similar to bad and not very similar to good. And therefore, we're going to prevent the execution of the file, and we're going to take it away from you so you can't run it again. Now, let's now up the ante even more and do that with a sample that I just fabricated right now here in front of you, and see if I can bypass the solution a little bit here. And the answer is no, I can't. What happened here is the exact same thing. The AI component of our solution saw this executable and went, sorry, this too is far more similar to bad than it is to good, and therefore I won't allow it to run. Now, the final thing I want to show you here, folks, is this all was done by a mathematical model, which is implemented in the form of this little DLL file here, but look at the date modified. The mathematical model, the data science behind this, was from 2015. So there's a tangible, concrete example of this temporal threat predictive advantage. So if we can stop today's threats that I just created using a mathematical model from 2015, well, then that's a predictive advantage of, I haven't counted it, but many, many months. Now, let's look at a slightly more modern threat type. Over here, we're going to look at what some people call a fileless attack. And the reason I'm going to demonstrate that for a little while is fileless attacks are extremely common. Attackers, to an increasing intent, no longer necessarily always rely on traditional malware and compiled binaries, but they certainly also try to take advantage of built-in components of the operating system and scripting technologies. And sometimes those scripting snippets, those little bits of code, arrive on the device, on the endpoint, on the cloud workload in the form of what some people call a fileless attack. So I've come up with two examples here. Here's an example of something that I'm just going to show it to you here is unquestionably benign. This is simply a script that writes hello world. It does a dir command, it lists whatever is in my folder, and then it says, the script ends here, and then it pauses. So I think we can all very quickly agree that this is unquestionably benign. So let's go ahead and try and run this and see what happens. And as no big surprise, this script runs because it's benign. Now, let's take an example of something that is absolutely not benign. This is an example of a malicious one-liner, a piece of scripting code that is also applied on the command line. And without going into too much detail, this is a piece of code that will retrieve what appears to be a PNG file. Then it'll use an otherwise perfectly benign portion of the operating system, namely something called searchutil, to transform this file into a malicious binary, and then the script will pause if it's allowed to run. So let's try and see what happens if I run this piece of code. We saw not a whole lot, and we see a pop-up from the security agent saying, I saw something that didn't look right, and therefore I stopped it. And so what happened behind the scenes here, folks, is that the second example here, the malicious one-liner, as with the first one-liner, was compared by a mathematical model that we've produced using data science. And that mathematical model said, no, sorry, this malicious one-liner is much more like bad than it is like good. And because of that, I won't allow it to execute. So in summary, we've seen now a couple of examples of how data science helps you defend against that which you have not necessarily ever seen before. And you don't even need to know all the ins and outs or the specifics of any of these threats. All you need to know is that data science has produced a model that very clearly specifies what does safe look like, what does unsafe look like, and it automatically compares the threat in question to that mathematical model and makes a safe decision on whether that piece of code is allowed to execute. So let me see if I can toggle back to my first device here. Just give me 1 second here, folks. And so there we go. Now back to the presentation. Our technology is available across a very, very wide range of platforms. Some are very typical cloud workload platforms. Other are probably a little bit more towards the desktop. I'll just let this sit here for a few moments. And other than that, let's go ahead and move on in the interest of time. I'm going to go ahead and pass the baton to my colleague, Aaron Bryson. Aaron, go ahead and take it away. The floor is yours.
All right, thank you, Mikkel. I appreciate that. So what I want to do is offer another perspective for securing your cloud. So let's go ahead and move to the first slide. So when we talk about cloud security, there's a lot of cloud service providers out there. People are very familiar with ones like Amazon, AWS, Microsoft Azure, Google Cloud, Oracle. There's many more. These are some of the most secure public cloud platforms available, and they have a ton of user accessible security features that can be configured. They're very feature rich. And organizations that are building their own secure services or products or within these clouds must properly utilize those controls provided by those cloud service providers, but they also must implement their own additional security controls to mitigate the risk because it's a shared responsibility model. Now, that being said, when we say cloud security, depending on who you're talking to, you're going to get very different understandings of what that means. So what I'm talking about is someone who works in development versus operations versus a CISO versus somebody who works on the legal team, right? So an example might be if you're at a point where you are architecting your solutions and your services, you might be thinking about the data design. What is the data we're going to collect? Where is it coming from? How are we processing it? How is it being stored? How is it being transmitted? What are our legal and contractual obligations to our data consumers and data providers? Things like that, right? So you're thinking about, how are we engineering this thing? Do we want a serverless architecture? Do we want to go with a microservices build, or do we want to go with something more traditional? Further away from that, you have people who might be further along in the product development lifecycle, and they might have already figured out the design. They've decided they're going to go with microservices. They figured out what's going to be encrypted and whatnot. So now they're looking at, okay, now we have our apps, our data. What are our data flow diagrams look like? Are we ready for things like incident response if something happens in the cloud? What does our architecture look like, and how does that compare against our industry peers or other best practices? And then you have the configuration of the cloud itself, which is very robust, and I'm going to dive into these things in more detail. And then you have your more traditional methods or ways of thinking about security, things like penetration tests and vulnerability assessments. So I'm going to dive into each of these in more detail, but the idea is to give you the idea that when you talk about cloud security, the lens absolutely matters. So let's go ahead and move to the next slide. So since cloud service providers offer this abundant amount of features within their hosting services, they have things like compute and storage, content delivery, security management, network infrastructure, physical hosting facilities for their tenant organizations. And all of these things contribute to a really complex environment, especially with the differences in these ownerships, the ownership models that you can buy. So for that reason, it's really important to test your configurations, not only the configuration of the cloud features itself, but the application code or assets that you deploy within that environment. It's not uncommon where I've seen a single enterprise to have two different clouds. They have Azure and they have AWS, and they're doing different things in both. So the object is to identify the risks and other potential issues or failures. So what we have listed here is, this is just a handful of different components within AWS. And the reason for showing you these is to give you an idea. When I talk about security or configuration of AWS, what am I talking about? When I say access, identity and access management, or IAM, you're thinking about things like password policies, multi-factor authentication. How often are you rotating access keys? Do you have a whole bunch of administrative accounts or user accounts that are no longer being used? Maybe you had engineers or DevOps people who left the company, but their accounts still exist. That's one type of check you're doing. But then you start looking at another component of your cloud, logging. What logging data do we have enabled? To what depth level are we collecting log data? How are we collecting it, monitoring it? Are we alerting on it? And are we encrypting it? Are we rotating it? How long are we storing it? You get into all these sort of log management practices. And that alone within itself warrants a lot of discussion and planning, because then you have to start planning for things like incident response if something happened to your cloud. What happens if you're just trying to support application performance or server performance, or balance, optimize your costs with your elastic cloud. So all of these little details, when you just get into something simple as logging, actually can blow up real quickly into affecting a lot of other things. When you're looking at monitoring, the thing about this is there are so many tools within these cloud environments that you can collect a ridiculous amount of data, more than you may be capable of handling, processing, or even taking action on. So then the question becomes, well, what features are on by default when you become a customer? Which ones are off? Of the ones that are on, do I need them? If I don't need them, can I turn them off? And what does that imply? The thing is, anything you turn on not only increases your cost and complexity of your cloud ecosystem, but it also increases your attack surface. So for every feature you turn on or off and configure, you really do need to take a close look as to what is that doing, what other ancillary effects is that having on your ecosystem. Then you have your networking, security groups, ingress, outgress ports, TCP, UDP ports, and so forth. So that being said, when you're looking at these things, it's really important to have someone who's very familiar with these cloud environments. You can either work with your expertise in-house, acquire third-party expertise. You can also even work with the cloud providers themselves to have them essentially guide you into using the best practices and properly configuring these things. But unless you have really intimate knowledge about how all of these things work, how they piece together, how does it support your application, your product, or your service, it's going to be really difficult to get this right. And so this configuration review perspective that I'm talking about primarily applies to your DevOps people, primarily your operations people, the ones that are actually have administrative rights, they're managing the cloud, they're going in and doing the configurations and that sort of thing. So this is, when you say cloud security to them, this is likely what they're thinking of. And if you don't communicate with that sort of lingo or vernacular, then there may be a disconnect as to what you're trying to talk about. So let's move on to the next slide. Oh, sorry, the one after that. So then you have your more traditional perspective on cloud security. So let's say you've done everything else. You've configured your cloud securely. You've got your firewalls and logging locked down. You've designed the data the way you want, network segmentation, all that stuff. Now you actually have your production applications. Now in this case, this is Bank of America. This is just an example. But what you see here is they have a cloud-hosted web application. That's a very common front end for their users. But over on the right side, they're advertising their mobile applications. So now when you start talking about cloud security, if you're talking to a developer or someone who's in charge of this particular product, security to them means something totally different. They're no longer thinking about it, things like, oh, our access keys in AWS being rotated. No, they're thinking about, can my mobile app be hacked? Do I have any vulnerabilities in my web application? Is it possible for user A to access user B's bank account information? Or is it possible to, fraudulently trick somebody into wiring money to another account? They start thinking about security in a very different way. So when you get into something like web application vulnerabilities, you're talking your traditional or more common AppSec type security checks. So you're looking for things like cross-site scripting, session management issues, authorization authentication issues. And when you go to assess these things, or you're working with a third party for, let's say, your annual penetration testing requirements, the things you're going to be asking for and the things that you're going to be receiving in the form of a report and your vulnerabilities and findings is just going to be vastly different. And the actions that you're going to take based on those are going to be primarily targeted towards your developers and those product stakeholders. Maybe some infrastructure components in there as well. Similarly, the same people that are developing your mobile applications are not necessarily the same people who are working on the web applications. Then they may not even be the same product group or engineers. That's especially true if you are supporting multiple platforms like iOS or Android. But now, if you have a mobile application ecosystem, now not only do you have your AppSec problems to worry about, you have additional mobile app-specific things to worry about. So things like, can my Android application or my iOS application be reverse engineered? Can they disassemble or modify the code, disassemble it, and find sensitive information within the mobile binary itself, which is hosted out there in the in the App Store or available for download on your website? Then you're looking at things like, well, what if somebody has access to the mobile application? Can they manipulate the communications between my mobile client and my backend mobile APIs that support that mobile application? Is that connection between the mobile application and the backend server guaranteed if the person is using our app at a Starbucks on an open Wi-Fi? What if that person's iOS device is jailbroken or their Android device is rooted, right? Then any assumptions you may have had about building security into your application or relying upon those provided by those operating systems and platforms goes out the window. And so what you're left with is only the security that you've actually engineered yourself into your apps and into your backend systems. Let's go ahead and move forward. So not everything in the cloud is an app. You may not have a mobile app, you may not have a web app. What you might have are embedded devices or IoT devices, connected cars, medical devices, client-less or thin client or thick client type products that are connecting to APIs hosted and provided in your cloud. So what you have in front of you here is really just a single microservice. This microservice, it's publicly documented. In case you're wondering where it's from, it's actually for Bank of America. This is so that developers can come and create apps that talk to their backend services. But I'm gonna use this as a great example of how complicated this can become. When we're thinking of security and we wanted to initiate a payment, if we look down here sort of towards the middle, you'll see the debtor account function, and it says there's an identification number and a currency, and just above that you see a value and the type of credit. So it could be credit or debit, right? Now what happens if I'm logged in as Aaron and I want to send Mikkel $1,000? But so I invoke this API, but I come in here and I say, well, I do want to send him a value of $1,000, and it is going to be a debit or credit, but the identification number of the debtor account, while that might be mine, I actually want to change it to some other random number. Maybe I just increment it by 1. Well, what user out there or bank account user does that identification number belong to? And if I change it, will that person's account now be debited $1,000 instead of mine, even though I don't actually have control or access to that user's account? So that's just one. This is one thing that what penetration testers would do, is they would go in and they would manipulate all these parameters in varying combinations. What happens if I change the execution date? What if I change the number to a negative value? Do you deposit money to my bank account, right? So these are the sorts of things that developers would and your QA teams would really need to be working on as part of their test cases and security. But this is the code that's ultimately running and hosted in the cloud. And let's go ahead and move to the next slide. Now, another way to look at this is, so one thing is looking at those APIs and how those can be manipulated. You're going to want to consider the design behind those. And an example is, are you able to detect when the house is burning down? Actually, before I get into that, the next part is when you're just thinking of your cloud, right? You often end up with this range of public IP addresses, these domain names, these bucket names, and so forth. But when you go and you say, I would like to do a penetration test on my cloud, I would like to make sure my cloud is secure, and you go to a company that provides those security services or to your security team, you really got to qualify what that means. So if you got to say, I want you to look at my APIs, I want you to look at my apps, my mobile apps, I want you to look at my configuration, or I want you to look at our public-facing assets. So maybe what you're actually asking for is more like an external penetration test, or maybe what you're asking for is a general vulnerability assessment of anything that's public-facing. Now, the reason this matters in the way you communicate this and understand what it means is because many organizations have some sort of obligation to perform a certain amount of secure due diligence through the form of third-party audits, penetration tests, of course, their own internal security and engineering and so forth, or DevSecOps. And getting that lingo down and knowing what it is you actually need to meet your minimum obligations, and then knowing what you need to do in addition to do right by your, let's say, your customers, is really important. And so when you're looking at something like your external facing assets, you're no longer looking at any of the stuff I previously talked about. Now you're just looking at, can somebody guess the name to my S3 bucket, and is it publicly listable or readable? In other words, you could browse to this debit card's HTTPS URL and see everything in that S3 bucket, assuming you can guess it. Similarly, when you're looking at these IP addresses and these domain names, when someone goes and looks at them, what's sitting there? Is it a service? Is it an app that's hosted there? Is it one of your EC2 instances? Is it patched? What TCP ports and UDP ports are open? Is it firewalled off? Things like that. Okay, let's go ahead and move to the next slide. Now, given that there's a lot of considerations when you're talking about cloud security, it's really important to think about, one part's the engineering part and building everything and setting it up. The other part is to think about what happens in a worst case scenario and preparing yourself for all the hard questions and all the hard scenarios. Not just, I'm not talking about if you got compromised. I'm also talking about, you have like something like GDPR auditors coming down, and they need you to show your level of due diligence and how well you've engineered things, how well you're prepared for these different scenarios. That's just one example, but it could be any number of compliances or regulations, or just a client that in particular is very stringent in their requirements and that you're working with. So Matt, so going back to that example when I was talking about the banking API, if someone had modified the debtor account number, do you have the ability to detect that? Do you have any level of logging that would even catch a subtle manipulation like that in the HTTP request? Does it know that someone's debtor account that was modified doesn't match the cookie that they had when they were logged in, right? And if you can't detect that and you didn't plan for that in your engineering, you're not capturing that or logging that, then it's going to be completely invisible to you. So how do you deal with it if someone's abusing your APIs in this way? Similarly, if someone in somehow a configuration changes, maybe all the egress ports are opened, or maybe access keys were modified, or maybe some new user account was added for an unknown user, are you aware of these things? Are you seeing these things? Are you alerting on them? Because that's something your operational team is going to want to know and be able to address right away, because that means something could be going on there. Similarly, if something's going on with your applications, let's say you had a mobile application and somebody reverse engineered it, found some particularly vulnerable code, maybe they modified a library and then put out a sort of, let's say, a hacked version with some malware embedded in it out there, and people started downloading sort of a backdoored version of your app, would you know? Right? If you don't have the right instrumentation within your code, and you don't have the right instrumentation on your backend, these are things that you will just simply never be able to prepare for. Now, moving on from that, let's say there is something that happens. The first thing you're going to want to do is contact your CISO if you are not the CISO. That CISO is going to want to immediately contact the legal counsel. As you can imagine, if you imagine a typical corporate environment, you have a geographically dispersed cloud. You got customers from America, South America, Europe, and you got customers in California and New York. Well, not only are you dealing with these sort of international and global level regulations, but you're dealing with local, state level stuff as well. That being said, your requirements to respond, to put out notice, and to do them within a certain timely manner or within a certain within certain boundaries becomes really complex, and it's more than anything that your developers, engineers, security people, operations are going to know. You really need your legal counsel. Not only that, it's really important to understand client-attorney privilege and know what you can and can't say, what can and can't be talked about by email or chat or so forth. And this is to protect yourself and your organization. You have to be very careful when something happens, and it's absolutely crucial that you seek advice of your legal counsel. Now, in order to prepare and have those facilitate those conversations with your legal counsel well, you need to have a very good understanding of your own ecosystem, which goes back to all the stuff we talked before. Now that the next thing is, let's say you want to have cyber liability insurance, which is not uncommon these days. In fact, more people are buying it. Well, I can tell you that these insurance companies, in order to underwrite any policy that you may want to have for your company, is going to have, they're going to require you to have all these kinds of ducks in a row. You're going to have solid security. You're going to have proven assessments, penetration tests, vulnerability reports, threat modeling. I mean, you name it. It's going to vary by insurance company, but they're going to expect you to have a pretty mature level of things planned for, documented, and so forth. And then the other part you need to understand about insurance is that when you buy insurance, you are only buying a certain level of incident response from third-party experts. You are not buying a third party who's going to come and write emails to your customers and communicate what the problem was, how something got compromised and what you're doing about it. They're not going to go to your boardroom and explain everything to the board for you. I mean, they will support that, but they're not the ones who are going to be in the boardroom, right? It's going to be the CISO and the other people that are involved, the legal team and so forth. So it's really important to understand when you do get insurance where your responsibilities lie. and what you're going to have to plan for outside of what's going to be provided by those experts that the insurance is going to ultimately pay for. And that leads me to the incident response plan. Most people, and from my experience, are poorly prepared for their cloud incident response. What I mean by this is a lot of the way the cloud is engineered is generally to support the products and services. They're not necessarily planning for a worst case scenario. They might do the configurations, right? But let's say they have ethereal instances in the cloud. They're always coming up, being deleted. Maybe they have a serverless architecture, or maybe they're logging, but they're not logging deep enough for the levels that they're going to need in a worst case scenario. So one of the common engineering I guess piece of advice is when you're an architect is to log 1 or 2 levels deeper than you think you will ever need. Whether you're just doing this for application performance, for data analytics, for security monitoring, whatever it may be, something to consider because it's crucial to have this data in order to put together a real incident response plan that works for your cloud ecosystem. And what you're doing for one environment, let's say AWS, is not going to be what you do for Azure. In theory, at a high level, it may be, but not in practice. The tools, the approach, everything's going to be different. So let's see how we're doing on time. All right, so let's go ahead and move to the next slide. All right, well, thank you. And I'm going to hand this back over to Mikkel for some Q&A.
Thank you so much, Aaron. And yeah, at this point, folks, by all means, if you have any questions, I've seen a couple of them being submitted through the questions window. If you have any other questions, now is a fantastic time to post them. There was one question that came in about the difference between the version of the Cylance technology that I showed earlier versus the what's called Smart AV or the home use version. And there was a question of can I address the difference, and the difference, well, there is one, and the reason behind it is that if you look at the type of threats that an enterprise needs to concern themselves with versus the type of threats that someone who has a single PC or 2 or 3 PCs in their home, the threats are somewhat different, and so the products are also subtly different. The home use version is very much focused on simplicity, ease of use, and ease of deployment, and yet it still gives you the same extremely capable mathematical model. It is, in fact, the same math model as the enterprise version. There was another question about running our technology on a Solaris system. And while we don't have an agent that runs directly on Solaris, we may want to, or may find that if we were to engage in a little bit more detailed conversation around the architecture around a Solaris platform, that there may be things we can do if we look at the environment in a greater picture from a higher level. So those 2 questions came in. If there are any other questions, Aaron, go ahead.
Yeah, so another one that commonly comes up is regarding how do you run AV in the cloud or endpoint protection. So do you run it on your base operating system, let's say your EC2 instance, or do you run it on the Docker images or containers themselves? And the answer is it's actually both, but there are some caveats and discussions that it warrants deeper discussion to look at your specific environment. But often you definitely do want to have this kind of endpoint protection within your cloud environment on your servers, and you may even want it within your virtualized servers or containers as well.
Excellent point, excellent point. Folks, if there are any other questions, we're happy to take them. Go ahead and submit them through the questions window in your GoToWebinar control panel. I'm not seeing any other questions, so let me just poll the audience one last time for questions. If there are any questions or comments, by all means, let's hear them. We're happy to discuss. We're happy to elaborate.
All right, and while we wait for a minute, I would like to let everyone know that you can find your CEUs for all completed webcasts by logging into your SANS portal account, navigate to your account dashboard, and click My Webcasts. You can then download your CEU on the right-hand side of the web page.
Right, Carol, I'm not seeing any further. Oh, here's a question. Plan for Cylance Protect on mobile devices. The short answer is the future will the future will tell. So far, it's a space that has been a little bit difficult to really get into. Primary reason is if we look at the technical properties of one of the biggest platforms out there by ubiquity is Apple's iOS. It's not that we can't or won't build a security agent for an Apple iOS device or an iDevice. It's more a matter of getting access to the right kind of APIs. And I'm hearing from our engineering teams, and that this has always been the case, that there's just a little bit too many restrictions placed on software vendors, of which we are one, in order for us to be able to build a viable agent for iOS.
Yeah, in order to do that, it actually requires a much lower level ability control of the system, of which is purposely locked down by Apple and Google on their devices. And so in order to make that a reality, I think it would have to, either they'd have to open up the platform or system to vendors, or you'd have to work very closely with them. And in practice so far, I haven't seen them open up their operating systems like that to anyone.
There's another question that says, that reads, elaborate on the future of SDP versus VPN.
Can we get some clarity on that question?
Yeah, Aaron, Pippin, if you want to maybe elaborate on that question a little bit. The person asked asking about it, if you can go ahead and elaborate on your question a little bit.
So I do need some more context on that, but perhaps what we can do is they can reach out to me after this, and I will have a follow-up discussion.
Okay. Any other questions from anyone? All right, the gentleman that was asking about the future of SDP versus VPN is stating in the questions window that SDP is being said to be more secure and flexible than VPN when it comes to apps moving into the cloud. Aaron, Bryson, does that help answer the question?
A little. So here's the thing. When we talk about apps related to VPN or its potential replacement, the thing is that you have to think about in what context you mean. So what I mean by this is, a lot of times when we're talking cloud, people are talking about an end-to-end connection between their corporate network and their cloud environment, or between systems within their cloud, within the cloud itself. Every now and then you will see an application that's designed with additional security controls, where the application itself running on the mobile device actually will establish a VPN connection to some sort of backend. So it's not necessarily doing a REST API over HTTPS. They establish some other method of secure tunneling. That being said, depending on the context in with which it's used, I can tell you that if you're trying to use it with a mobile application on the device versus using it, as I described earlier, just with the backend only, it's going to come down to how well those frameworks, let's say like the Android SDK, for example, or some third-party library, can actually support this new technology, and if it's actually it's feasible to maintain it for that particular product or for that cloud. I think it's very promising, but I think it's going to actually be a while before that becomes implemented in practice in anyone's environment.
There's a question from Fabian saying, thanks for referencing cyber insurance. How would you demonstrate the effectiveness of this system to an insurer in order to help establish the high level of diligence?
Okay, so it's actually not you going to the insurancer or insurance provider and doing it. What they when you talk to them, they actually give you the guidelines, and they assign the assessor or auditor, and you kind of really follow suit with them. And because they work with let's say these independent parties, those independent parties already know what to look for, and they create the output or the report that goes back to the insurance company for you. So that being said, what I would do is just work with your insurance company, and you don't have to necessarily worry about the reporting. But what you do need to worry about is making sure that you have sufficient policies, procedures in place. Occasionally, they'll just look to see that they exist, but they may randomly spot check things. So you might say, oh yeah, we definitely rotate our passwords, or we definitely have two-factor enabled, and they may say, well, show me, right? Or you might say, yes, we have these certain controls within the cloud configuration, and they may say, okay, well, run the script and show me the output of your cloud configuration so I can verify. So having all of those things in place and planning for them is going to be crucial. And I recommend getting ahead of it. In other words, don't wait until you get to that point and then you maybe don't pass, because what's going to happen is you may end up with a higher rate than you want. It's better to kind of get things fixed in advance and prepare before you go in trying to get your policy. But I understand that sometimes time is of the essence, and you may not have that luxury. In which case, then it's you just got to roll with what you got.
And both Aaron, Pippin, and Fabian, thank you very much for those comments. It's a pleasure speaking with you today. So thank you for the kind words.
All right. Well, thank you so much, Mikkel and Aaron, for your great presentation, and to Cylance for sponsoring this webcast, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.